Some countries, they have a large industry, but the industry does not have almost no R&D, no research and development. You would like to have at the end students which can go abroad, which can make projects then abroad, and maybe then they come back also to the country. And so they are ambassadors outside, but of course they are inventors then inside. Maybe not the future, but maybe now, before we have a better technology, it might be the next step. My advice is always to study hard, to get the best grades, of course. The first step, of course, then to go abroad, to go for a master program at an internationally recognized institution, and then to come back to become a leader, let's say, in the field of chemical engineering. My name is Olaf Hinrichsen. I'm coming from the Technical University of Munich in Germany. So first of all, thank you very much for the warm welcome here in Uzbekistan, in Tashkent, at the new Uzbekistan University. I had a good welcome, a lot of people I met already, and I'm happy to answer, of course, questions with respect to chemical engineering in context to the world questions, and because I'm a trained chemical engineer. Well, we as chemical engineers, we will solve, of course, the major questions with respect to the energy transition as well, because there will be new processes which have to be designed, and that's why the process engineers and the chemical engineers are for. They have the knowledge to do that, so not only today, but also, of course, for the future, because there will be, of course, issues for climate changes and energy resources, energy questions, and that's actually one of the main topics for chemical engineering. Well, for climate changes, of course, what we have to do is we have to reduce, of course, the emissions. So that already in the past we did a lot for that, in particular for catalytic conversion and also for implementing new tools. But on the other hand, of course, we have to think about how to get then renewables, how to get, of course, more energy from the sun. That would be, of course, one point. So actually we can address this field in terms of photocatalysis. So that may be an emerging field for the future, just to use the energy of the sun to convert then to energy which we can use here, in order to reduce then also the emission, and also to reduce the amount of conventional energy carrier we are taking today, like coal or like oil or gas, etc. If you think in terms of process engineering or processes, then of course right now what we are using process design tools, so simulation tools, in order really to design processes. And but for the future, of course, there is a machine learning tools. Machine learning tools can be applied in order to design maybe then better processes. Of course, we have to teach these machine learning tools, and that's actually the basics we have right now. We have already the tools for that. But then, of course, the perspective will be then designed processes by machine learning tools. I think there is a big demand for that, and there will be also a bright future for that. I think the plastic waste. The plastic waste, the problem of plastic waste has to be solved. This is a real issue. If you go to the ocean, and if you see all the plastic in the ocean, and if you see all the plastic we are producing and we are just throwing away, this should be solved. This is a major issue, and that's why there are a lot of startup companies in Europe which are working, also in the US. So they try to solve the problem of reducing waste, and of course then to use plastics again in a circular way. So circular economy will play a major role in solving these problems. Well, there's one simple example, because in many countries, the plastic is not recycled, it's just thrown away. I mean, in Germany, we have a recycle system. So we take the plastic, we collect the plastic, and then we just recycle it. So we produce it back to the market. I mean, this has to be done, of course, in all countries because it's quite easy to do it. Just to give you a simple example also for the Philippines. Philippines consists of a lot of islands. And if you go to the beaches there, some of the beaches, they're just wasted by plastic. So the easiest way, of course, would be just to collect the plastic, put the plastic together, and just to have small, decentralized factories for producing oil or something like this out of that. That's maybe not the future, but maybe now, before we have a better technology, it might be the next step. It's easy. So you have to convince also people to do something. And then in order to do the next step, because once they see, okay, I can collect something, I can bring it to a station and I get something valuable out of that, then I do it, of course. And that will help. So at the end, I think the easiest point would be first maybe to convince people what they have to do. Yeah. I think that strongly depends also on the country. If I go to my country, so if I make a comparison from my country, then of course I can say, well, sometimes it's good because we have a different funding system also. So we have funding for basic science, but we have also funding for applied sciences. Basic science, of course, goes mainly to the universities or to other organizations like the Max Planck Society or Helmholtz Society. So we have different societies working on a different level also of application. So I think this is nice because it's fundamental research. And of course, we need fundamental research, in particular in Germany. But of course, for applied research, then it's always interesting also to have the industrial partners on board. Because as soon as you have industrial partners, you would like to invent also something, you would like to have at the end an application, you would like to file patents, of course, also you would like to file knowledge. And that's why our government, of course, also is doing funding for these type of research. That's very important, I think. So you have to look how your country is organizing the research funding also. And the broader the research funding is, from fundamental research to applied research, the better I think it is for universities and industry, because they work close together on one aspect and maybe they can learn from the fundamental research as well. And of course, you have to look also how the research is done in the industry. I mean, this also strongly depends on the country. Some countries, they have large industry, but the industry does not have almost no R&D, no research and development. So they say, okay, we just go to the universities and they will do it. In our country, it's different. So in Germany, we have also large R&D divisions in most of the companies. And they work, of course, then close together with the universities. And of course, they take then also the PhD graduates or the master graduates for research. And I think this is also important for country. I think the chemical engineers in particular, they have to work with other fields. I mean, this is important so that we get basic ideas also from fundamental research, and we can have a look at this and then we try to transform this into applications. So I think this is the major point. So we have to look, let's say, if we are looking for products, we always have to look maybe to catalysis, because a lot of products are done by catalytic processes. So that's why we have to see, okay, what are the fundamentals then in catalysis? Just the classical road now is to produce a lot of products is just by using maybe feedstocks, which are known, gas, oil, sometimes coal. So But for the future, of course, the sun we should use, because the sun is the major supplier of energy. So that's why we have to have a look, of course, at basic science, fundamental science, and then we can produce, of course, better processes, and that's, I think that's one goal for our chemical engineering and process engineering fields. I think what you're doing at new UU, at least what I see, because I'm involved now since almost 3 years in this project, so I think you have a big future because you're teaching your students at an international level. So you would like to have at the end students which can go abroad, which can make projects then abroad, and maybe then they come back also to the country. And so they are ambassadors outside, but of course they are inventors then inside. So actually this is a very good idea to put a lot of efforts into the education of young students and to teach them so that they can go abroad, that they get an international experience, and then they will come back with ideas, etc. They will settle down, and then maybe they have ideas for startups, etc. And that's how it grows. This is, I think, that's the best idea, and new UU is doing fine with that because you all have the ideas to do this, and so yeah. I think they have the potential, if they have chosen the study programs here at UU, to go abroad, to enter master programs, to enter PhD programs at internationally recognized institutions, because then they get the knowledge from these international institutions, and then they come back and try to teach here maybe also other students, etc. And so that's a good idea how to do it. And maybe I give you a personal answer for that, because I'm a trained process engineer. Then I did my master degree in chemical engineering, and I did my PhD in catalysis because I was fascinated by catalysis. So actually a field fascinated me, and also a person behind that. It was my PhD advisor, Professor Ertel, who gave me the inspiration, well, why should I do it? And I think that's the best way. So the students, they should pick the topic which they are interested most. So that's important, because once they are fascinated by the topic, they go abroad to institutions where they find maybe also people inspiring them, and then they come back, and then they become, of course, then also inspired by the field. They become, of course, then a leader in this field. I think the community. It's always a community, so that means you have to talk to different communities. So you have to look also what other people are doing so that they can inspire you. I think this is very important. So you do not have to be just in the fields of chemical engineering. You have to talk also with people from chemistry, from material science, from process engineering, so from different fields, because they have to give you maybe some ideas. So I think this is important. So it's just not one person. It's just like it's a lot of persons who tries to convince you also, and so that you can go forward in your field. I think this is important. I liked chemistry and physics, but I was also interested in mathematics. And that's why I thought, oh, maybe I can take this knowledge and maybe I can use this knowledge as a foundation for more applied technology. And so that's why I came up with the study program Energy and Process Engineering. And so I kept this field also and changed a little bit to chemical engineering. But at the end, as I said before, once I entered the catalysis, then of course I was inspired to get the knowledge about catalysis and to combine also catalysis then with my knowledge in chemical engineering. So I think this is bridging the catalysis and chemical engineering. That actually this was my dream, and so that's why I'm still fascinating by chemical engineering. My advice is always to study hard, to get the best grades, of course, and but I think the programs in chemical and materials engineering is well equipped with all the skills which you need, of course, then for pursuing studies in master programs in chemical and process engineering. So this always depends on the study program. There are general requirements for each study program, at least at our university. There is a minimum of requirements, and this has to be fulfilled. And once it's fulfilled, then of course there is an acceptance rate. And so based on this acceptance rate, then of course we accept also foreign students. So we have a large quantity also, a large number of foreign students studying chemical engineering at TUM. But the students, they get, of course, a foundation knowledge in mathematics, which is important. They get, of course, also the foundations in physics and chemistry. Nevertheless, they get, of course, also the knowledge in chemical engineering. So there are core modules in chemical engineering. So everybody worldwide has these type of core modules. And for this program is a special that we have also included then modules which are directed then also for material science, which is important, and I think which makes it also a different program than just from the simple chemical engineering program. That's why we combine this into this chemical and materials program. And of course, we were looking for having everybody who is interested in this field. And as I said, it's the first step, of course, then to go abroad, to go for a master program at an internationally recognized institution, and then to come back to become a leader, let's say, in the field of chemical engineering.